Good morning to one and all. Today we are going to discuss about the main paper of transforms and partial differential equation. That is the unit of partial differential equation. So we have to discuss about the partial differential equation. So first of all, we have a differentiation of y is equal to x square. So here that y is a function and x is a variable. Then here the value of y is we have to differentiate with respect to x. The dy by dx equal to 2x. So differentiate x square, it will be x power n method. So for the formula of n into x power n minus 1. So we can use that formula x square, that will be 2x. This is the normal differentiation. So in this normal differentiation, wherever we can use the old tool of mobile app and whatever, it will be the tool we are using in this differential equation. That is a very difficult, but the tool is very clear tool, but very difficult to because of x power, we have to x and y and multiplication of x and y and x mod y is that. So this multiplication, the calculation is very difficult to use that. So the whole program will be collapsed with using the normal differential equation. So that time we have to decide to segregate the variables. So that time we can start with the partial differential equation, that to be entered into the partial differential equation, that it is a PDE, that partial differential equation. Now we are using all the app will be only the PDE, that is partial differential equation. This partial differential equation, it will be using the every app. Their app, they have a separate folder. They creating the separate folder that mainly we can use that partial differential equation. So in this the version of ordinary differential equation, that is the one of the greatest part is PDE, partial differential equation. So in this partial differential equation, that is the only one thing, that will do only one hero, that's all. So that category. So whatever, see for example, u is equal to x square y plus x y square plus x cube y square. So in this equation, we are in this normally the ordinary differential equation, we can use that x and y both the variables. But here the partial differential equation, that we can use that dou u by dou x. We can use the symbol of dou. We can use that we can use that d dou x. Then the only hero is x. So we can use that only x. So x square is 2xy because of y is a constant. So constant will be same thing. So 2xy plus y square, because of x value is 1 differentiation, and 3x square y square. So this is the partial differential equation. Not only you can use that partial differential equation only in the app tool. This is the easiest way, and acute value is given to the partial differential equation. Then equation signals and the poles, everything will be a very clear idea that given to the partial differential. So in this tool, so in the partial differential equation, we are using the dou u by dou x. So only one thing is, this is the main tool. The only one thing is only one hero in one movie. So that is the category in this dou u by dou x. So only we can use the x, the dou u by dou x only. So x is the hero. We can use that dou u by dou y. So here only the hero is y, not only x. So that method we can use that. So this is the very easiest tool to transform the equations. So the previously the last 5 years before, we can use that ordinary differential equation. That way is very difficult. So after that, the partial differential equation. So it's a very easiest way. That only we can use that all the devices, IC chips, everything will be very accurate values given. So one is the way of the partial differential equation. So that is the very important. Thank you.